Hello, everyone. Welcome, and thank you so much for joining us today on our webinar on how ICIJ used Neo4j to unravel the Panama Papers. My name is Corey Brickman, Marketing Community Manager here with Neo4j, and I am thrilled to announce Cabra, Data Editor of the Data and Research Unit at the International Consortium of Investigative Journalists. Mar, we're so excited to have you today. I will go ahead and hand it over to Mar. Thank you.
Great, thank you very much. Thanks so much. I want to thank Neo4j for allowing us to do this webinar. I hope it is useful to all the people that are coming, and of course we'll be taking questions at the end. The idea of this webinar is to explain how we worked at the International Consortium of Investigative Journalists with graph databases, and especially with Neo4j, to unravel the Panama Papers, which is the biggest leak in journalism history, the biggest collaborative investigation in journalism history, and technology had a lot to do with it. So you can see the presentation hopefully in your screen. You can also save the link for later in this URL that you'll be able to see at the bottom of the screen, bit.ly/ICIJ Neo4j. So you can review the slides later or move forward to see what I'm saying, but don't go that far. Just follow me step by step, please. Basically, I want to start by introducing quickly what ICIJ is, because I hope that some of you already know who we are, but in case you don't, we are a network of almost 200 journalists based in 65 countries that try to do cross-border stories through collaboration. The way we do our work, and you can read more about us in our website, is we have a small team in Washington, D.C. and other parts of the world, and we knock on the doors of media organizations and journalists all around the globe, and we get them on board for projects, and we work in all these countries, gathering this local knowledge from these countries: Spain, France, the US, Chile, many of the countries that you can imagine. And I don't know how much you know us. I like to refer to this Simpsons character saying, you may remember me from, you may remember us from some of our biggest investigations that are all connected to leaks and the offshore world. Our first investigation that was connected to the offshore world, we published back in 2013. We called it Offshore Leaks, it was published in 2 installments, one in April 2013 and one in January 2014, connected to China. And basically, back then, we dived into 260 gigabytes of data that exposed 2 offshore service providers, 2 companies whose business is to create companies in tax havens for other people and for clients all around the globe. We later published another investigation called Luxembourg Leaks, published in November 2014 and connected to secretive tax agreements between multinational corporations and the government of Luxembourg. And our latest investigation before Panama Papers was Swiss Leaks, based on another leak, this time of HSBC in Switzerland, the clients of HSBC in Switzerland and their money, around 100,000 clients and around $100 billion connected to Swiss bank accounts. But that was the past, or our present, I guess, until we published the Panama Papers in April 3rd. This year, we started publishing this investigation that helped us dive into the offshore world like never before. We gathered a big team of almost 400 reporters, and we dived into 2.6 terabytes of data, 11.5 million files. So how did everything start? Well, this started with a shock. As you can see, the scale of the leak, you can see on the screen right now, was massive. It was much more than we had dealt before. Of course, for those of you that come from the corporate world, 2.6 terabytes is nothing. But as you can see with the comparison in the screen, well, for us, 2.6 terabytes was bigger than anything that had been done before. Cablegate and WikiLeaks, or the previous leaks investigations that I just mentioned that we had done in ICIJ. So it was a shock at first. We're a team of reporters and have a small team of developers. And the shock was then turned into a challenge, right? And we thought that that was an interesting challenge to take on. These 2.6 terabytes were basically internal files from a company based out of Panama called Mossack Fonseca. That is one of the five biggest companies in the world that create companies in tax havens for clients all over the globe. We saw connections for more than 200 countries, and it was one of the biggest companies in the world, and therefore the clients that it had were high-profile clients. One of the questions we get a lot is how how did we get started with this? Well, it was a leak, as you can see. Everything started with an invitation or a source, an anonymous source, reaching out to reporters in Süddeutsche Zeitung, newspaper in Germany. They received some messages that you're seeing now in your screen saying, hello, this is John Doe, do you want data? And of course, the typical answer of reporters is, yes, we're very interested. They agreed to keep the identity of the source anonymous, and then they came to us to work on a global scale at ICIJ. You're seeing now in the screen the two reporters that got the leak, Bastian Obermeier and Friedrich Obermeier. And I like always highlighting the fact that they did something that was not common in journalism, that is not very common in journalism. When we get leaks in journalism, when we get exclusives, we actually normally hold on to them and don't want to share it. I call that Gollum journalism, because normally when we get an exclusive, we hold onto it like the ring, and we don't want to share that precious ring with anybody. And probably that's common and known to some of you that are listening, because that probably happens in your company too. Whoever owns the data, whoever has access to that data, is basically many times the owner of it and doesn't want to share it. So in journalism, it's difficult to share within a media organization, even more difficult to share with other media organizations. In companies, it's the same thing. Departments normally don't want to share. In governments, the same thing. Sometimes it's difficult to work across departments. So instead of plain Gollum journalism or Gollum data ownership, what they did is to share it with us, the ICIJ. And at the ICIJ, we have a very small team. And I like to compare us to a startup, because we only have a full-time staff of 12 people, led by Gerard Ryle and Marina Walker, who are the director and the deputy director. Then we have a US-based team with reporters and editors and an online editor, the person that deals with everything that we publish at ICIJ. And then we have a very important team, I would say, that's my team, the data and research unit. As you can see, we have two legs, one in Europe and one in Latin America. And we are 6 people. So basically, the technological side of the ICIJ is half of the staff. And of course, we do a lot of work with partners, and we have one reporter that is based out of Washington, D.C., but that basically deals a lot with African partners and travels there a lot, so we call him the Africa desk. As you can see, a very, very small staff. Of course, we hire more people when we do big investigations like this, but I think that the interesting model that we have built at ICIJ, that with this very small staff, we knock on doors of media organizations all around the globe and build what, I would say, is the United Federation of Planets in journalism. Basically, we get on board media organizations like The Guardian, like Le Monde in France, in Spain, El Confidencial. We now have on board, after publishing, the New York Times and the Washington Post, who are looking into these documents. And we ended up building, before publication and around a year ago, this big team of more than 370 journalists from 100 media organizations and almost 80 countries. And even though this is a very big team, as I was saying, this is spread across the globe. This is also in different media companies. So that's why I call it the United Federation of Planets. I guess the ICIJ is the enterprise for those Star Trek fans that might be following my metaphor. And we're basically traveling across the universe to actually visit different planets, different media organizations, and get them to collaborate with us. However, let me emphasize again that at the ICIJ, the data team is very small, and actually we only have 3 developers. So everything that I'm about to say about technology and platforms that we use to mine these 11.5 million files that we obtained of Mossack Fonseca, most of it was done by these 3 people. To me, they are my heroes because they are the ones that allowed us to look into this leak and these files like we are in the 21st century and not in last century. To me, I think that even though technology played a big role, the most important thing is the trust that we built. The photo you're seeing on the screen is me doing trapeze. I recommend you the trapeze. Is one of the most exciting activities you can do, but I also recommend it because it allows you to build trust. There's a moment where you're hanging on your trapeze where you just have to let yourself go and hoping that somebody will catch you in the other end, and if not, you will fall. Of course, everything is under control, don't worry. You have guides and you know, you won't die in the process, but there's this moment where you're just going to be flying and thinking, oh my God, will somebody catch me on the other end? And I think that the biggest element that made this collaboration work was the trust that all these almost 400 reporters put into each other. And it was a leap of faith. It's a leap of faith that nobody was going to talk about this. It was a leap of faith that people were going to collaborate. Of course, partners need to sign a non-disclosure agreement when they join, saying that they're not going to publish the information before, that we're all going to go out together. But in the end, that's pretty much the only thing that they agreed to. So basically, you just have to trust the team that you build on. And in this case, trust was key to keep this a secret for a year. These were some of the stories that we did. Basically, after a year investigating, we were able to expose like never before how the offshore world works. And we basically revealed that the offshore economy was being used by the rich and powerful in pretty much every country of the world, more than 200 countries. And we revealed how people from every single sector of society that was rich and powerful was used in it. We were able to reveal that around 140 politicians from more than 55 countries were connected to this data. We revealed that there were 29 billionaires from the top 500 richest by Forbes. We also revealed how there were enablers of the system in banks, and I'll show you that in a second. Basically, there were also celebrities. Anybody you can think of from every different sector was in there. The difference in this leak is that it was all high-level people. And among those high-level clients that Mossack Fonseca had were the politicians. As I was saying, 140 politicians. And out of those, there were 12 world leaders you're seeing on your screen here with these nice cartoons that we did, these illustrations. And basically, some of them were actually current world leaders, like the Iceland's prime minister that actually had to resign a couple of days after our revelation. his story, and you can already start seeing some of the graph work we did. In the right of the screen, you can see the graph of the company he had with his wife and that he had not declared. You can, in our interactive, you could also see a biography, connection of the offshore world. It's basically, he had an offshore company that held millions of dollars worth in bonds in Iceland banks that failed. And you can also see his response. And his response at first was denial, and 2 days later was resignation. So politicians, who were the enablers of the system and how banks were big enablers of the system. We discovered through data analysis that more than 500 banks had registered nearly 16,000 shell companies with Mossack Fonseca. And when we looked at the data, you could also see a trend in the request of these shell companies by banks, a trend that started spiking in 2005, right at the moment where the European Savings Directive was getting into effect, and right when the European Savings Directive was requesting foreign banks to actually withhold taxes of Europeans. In a previous investigation based on HSBC, we had already revealed that HSBC had been advising clients how to use a loophole in that directive that basically allowed clients to avoid being taxed. And one of that was basically using a company to put the account on, the name of the account on. So we not only looked at clients and the enablers, we also looked at why were these offshore companies, or what was the use of these offshore companies. As you can see here, a story by the Guardian data team that basically found out that nearly 1 in 10 of the 31,000 tax haven companies that own British property were linked to Mossack Fonseca, and were able to put names to the people that were owners of those properties and that were not known before, because tax havens provide secrecy and provide anonymity for the people that have a company offshore. So those were some of the stories you're now seeing on your screen, the front pages. We published all together on April 3rd, and that was one of the key things that allowed us to create a big wave trending topic on Twitter for days, and we also managed to basically put this topic again in the agenda. People got really mad. These are the streets of Iceland that you're seeing on your screen now. They couldn't believe that their prime minister and some other government ministers had connection to offshore companies and had not disclosed this information. And this is actually one of the biggest reactions we've seen, people understanding for the first time the power that this parallel offshore economy has in the world and how it is completely connected to the inequality that we now face in the global economy. But let me tell you how we worked with this leak. Now that you know what we discovered and you know the results, let me go a bit in depth into how we worked with this data, with these 2.6 terabytes of data. You're seeing on the screen now a graph of a organized crime network. Everything in our world happens in a network. I think that now that we all have Facebook, it's very easy to understand that basically there are connections, and that, you know, I know somebody and that person knows somebody else. And that is a graph, that is a network of people interconnected. And organized crime, works in networks. Drug trafficking works in networks. Money laundering works in networks, and all those networks are international, are global. So if they work in a global way, we need to tackle issues in a global way and finding the connections between the dots. And that's why the ICIJ built this multinational team to look into this data. We basically created a space, a social network. You're seeing some of the screenshots of our social network, which is based on an open source software called Oxwell that we have improved. And basically these this social network allowed us to communicate with each other every day and share what we had found. As you can see, it has a wall where you can see what is the latest in your network. People could also talk in threads. People could also share links and share files. And because it was open source and we could adapt it to our needs, our tech team basically added some security features that allowed us to have some security around this platform. Basically, you can see on your screen now the login screen, which has two-step authentication. So basically, the reporters that got into the platform needed 2 devices to identify themselves, a login and a passphrase, a long password, and then on top of that, they needed a code that gets automatically generated in their phone every 30 seconds. And that way, it's a better way to log in, in this platform, and make sure that it's that person and not somebody that is trying to get into it and hack us. Of course, let me say that all the tools that I'm about to show were chosen because we did a threat modeling analysis. Right from the beginning, we knew we didn't have governments as an enemy. We knew that basically governments were not a threat. We were not basically analyzing government data, NSA data, for example. So we were not facing the same security challenges like our colleagues that worked with the Snowden files and the NSA files faced. And that is why we were able to use many of these tools that you're about to see. So as I was saying, in order to work globally, we needed this global space, this global iHub to communicate every day and exchange messages and ideas and threats and tips and leads, everything that we found. I remember the day when we found Messi, the soccer player from Barcelona Football Club, and it was found by a reporter in Spain, a colleague called Marcos Garcia Rey, and he immediately posted it in the iHub, and within seconds we had reactions from Venezuela, from the United States, saying how great that finding was and that they were going to start looking into the documents immediately. Why? Because we believe in a methodology that we've called radical sharing. Basically, we share all the data with all the reporters that attend and participate in this project. Therefore, every single reporter in this project had access to these 2.6 terabytes of data. You're seeing in your screen the breakdown on the files. As I was saying, we had 11.5 million files. And as you can see, most of it were emails, emails from Mossack Fonseca, but there were also PDFs and images that took us a while to process. It took us actually months to process because most of them were not were images, so we needed to perform optical character recognition so that the computer could see inside them. Once we did this complex process that was able to recognize the text inside these files, we were able to put it in a platform that was based on open source software again, based on Apache Solar, on another user interface called Project Blacklight. And that was pretty simple for reporters to use. It's just a search box, as you can see in the top left of your screen, and you type in something and you then get results. The users that I have, I would say, quote unquote, my clients are journalists that basically range from very tech-savvy journalists or even developers that work in media organizations. And on the other side of the spectrum, we have journalists that are great journalists that are great at sourcing, but that are not very tech-savvy. So every single tool that we decide on to use basically has to be very, very simple, and at the same time allow for some advanced features. So for example, in the screen, you're seeing that it not only allows you to search, but it also allows you to search with proximity searching. So for example, you're seeing that I'm searching here for Joaquin Loera and proximity to, so that would mean Joaquin something Loera would also appear there. And you see I get a result called Joaquin Guzman Loera, which is the full name of El Chapo Guzman, one of the most wanted drug traffickers in the world that was recently arrested and that is in prison right now. We also did other features that allowed for batch searching and some other more advanced features. But I'm not here to talk about how we allowed reporters to search into the documents. I'm here to talk a bit more in depth about the graph database work we did. So allow me to move into that part now and highlight that within the leak, we had more than 3 million database formats, basically database records from Mossack Fonseca internal database. Basically the database of clients of this Panamanian law firm that was connected to more than 200,000 offshore companies in 21 jurisdictions, ranging from the British Virgin Islands and Panama to Nevada, Hong Kong, or Wyoming in the United States. So basically, before telling you how we worked with this this time, which you know the answer, we used Neo4j. Let me come back with me to 2013 for a second, because it's clear here in the screen that you're seeing that these clients that Mossack Fonseca had were a graph. But for us, from a reporting perspective, this was not so obvious 3 years ago. 3 years ago, when we were working with offshore leaks, with this other leak of 260 gigabytes, also connected to companies created in tax havens. This is how it would work. I would get a list as a Spanish reporter. I would get a list of names connected to Spain, and I would get a name and an address. And I know it's connected to Spain because, of course, it has an address in Madrid, Spain. Jaime Rotondo by itself, to me, doesn't mean anything, or didn't mean anything back in 2013 when I got this name. I could search for him. One of the things we do in reporters do is search in all the social media. This is his social media photo. It's public, and he's a lawyer. If you keep researching, you can see that he's a lawyer, and of course, as you know, lawyers have client confidentiality. So I didn't know what he was doing in the data. I just knew he was connected to some companies. By the way, those of you that speak Spanish or that have been to Madrid, you are probably already seeing some data quality problems. As you can see here, this name is actually not correct. There's an R that is there that shouldn't. If you look at Google, and you can see here, Monte Esquinza is the name, not Monte Esquirnza. So some data quality issues already there that we can see with this example. But basically, as I was saying, as a reporter, I got a name, a list of names, and this being one of them. I searched in Google, in social media, and I already also got in that list the connections of this lawyer connected as a director to 2 Cook Island companies. So I would get that in a spreadsheet, or actually that back then it was in an Access database. So then I would have to go back and go to the file of, let's say, Nautilus Limited, the second company, where he was a director. And then I would have to open up all the connections of that company. These are the connections. And here you see the directors, the shareholders, the secretary. And immediately there, I already saw a name that was, known to me, Carmen Thyssen-Bornemisza. She's a very well-known art collector in Spain. She was a shareholder, and she collects art. She has a museum in Madrid, and inside the documents, actually, there was a connection of a painting, this Van Gogh painting that you see there connected to Nautilus Limited. But as you could see, I was exploring things in a table format. So I would see Nautilus Limited. I would go to that file in my Access database. I would get all the directors and all the shareholders. And then if I wanted to know all the connections of Carmen Thyssen, I would have to go back to her file, expand the connections in tables, and I hope you're already understanding how labor intensive this was, right? Probably reporters back then at the time were doing what I was doing, which was getting a piece of paper and basically putting dots in a piece of paper and making a graph without knowing it, that I was doing a graph, just basically, you know, painting it to try to make this information understandable. Our brains are not wired to think visually, so that's why we use visualizations, even if they're in a manual form, even if they are just in pen and paper, to try to understand the world. So we were doing this throughout the whole investigation that we published in 2013, and then we realized that there was some potential get the world to explore it. So in June 2013, we published the Offshore Leaks database, allowing people to search through more than 100,000 companies in tax havens of that leak. Remember, we are in 2013 now, so 3 years ago, and we got the first contact with graph databases. You could enter a name and you could see some dots in the screen as a user, and you could just double click and the networks would expand. And now, just in this graph, you're probably understanding the network around Carmen Thyssen and this Nautilus Limited, this Cook Islands entity much better, right? So back then, this was a very, very, very successful product. Right up to publication of the Panama Papers project, this database was the most successful product the ICIJ, or our parent organization, the Center for Public Integrity, had ever done. Millions of people had gone into it, and we started using it from a reporting perspective when we kept looking into stories. So in the investigations that we did afterwards, we already knew that we needed graphs to understand the data better. So back to the future, or I would say back to last year, so already the past, but move forward a couple of years. We found Linkurious. Linkurious is a French software. It's a French startup. Basically, it's great to visualize graph data easily. Their tagline is correct. Basically, it allows you to explore these networks in a very, very easy way that anybody can understand. You don't need to be tech savvy. And through Linkurious, we learned about Neo4j, because basically you need to have your database in Neo4j, just plug it in Linkurious, and it immediately visualizes it. You can actually put this in your servers, you control the users, so you're basically not giving it to anybody. That's exactly what we needed. And but we needed to do some transformations because both in the case, we ended up having the data in SQL. And I guess many of you relate to this. Most of your databases of your company, corporate databases, must be, in the typical relational database. We used to have our databases in SQL Server, and basically we needed to transform them. Well, the good news is that thanks to our tool talent, through that allows it to extract, transform, and load data, we were able to actually transform the data from SQL to Neo4j in a pretty easy way. And we ended up having these 3 million files of database records transformed into SQL, from SQL to Neo4j. And this is just one example of how Linkurious looks like. Basically, you have a find button in the top left of the screen. You can just type in any name and you click on the dots, on the nodes, and basically just keep expanding. So the users, my journalists that are not tech savvy found this amazing because they just needed to expand dots on the screen, and that's something that anybody can do. But the good thing about Linkurious is that it also allows you to do much simpler stuff. Allows you to do simple stuff, and much more complex stuff, because thanks to the fact that it's being run by Neo4j behind it, you can also do Cypher queries and do more advanced stuff. So at that moment, I have to say, my journalists were amazed. We felt like we were having superpowers, and we were understanding reality in a way that we were not understanding before, because the first reaction was, oh my God, I did not see these connections before by looking through documents. Oh my God, I'm finding more stories. So to them, this was magic. I'm sure that some of you that work with graph databases have the same impression, that it's magic, that you're basically able to find connections that you couldn't see before when working in a SQL database. You could not see before when exploring documents. And the first reaction, again, from my non-tech savvy journalist is, I click on dots and I find stories. This is amazing. The second reaction is, I actually discover more stories thanks to fuzzy searching. Linkurious allows you to do fuzzy searching when you search. So basically, it suggests other names with similar spelling, which is very useful. For example, for these cultures where names are very common. So Garcia is always a Latin name, or Johannes is probably a name from a Nordic country. And I actually have the story of this reporter in Finland, in YLE, in public television in Finland, coming to me and saying, Mar, thanks to fuzzy searching, I found 4 more Finnish people in the database. And the biggest magic trick of all was the find shortest path that basically, without any code, allowed my users to basically put 2 dots, put 2 nodes in the screen and see whether they were connected. So reactions were very, 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 very good. Also, great reactions from those developers that knew how to do Cypher queries, so to explore a bit better the data. One good thing about Linkurious is that it also allows you to have public widgets. Basically, even though the tool is closed and used in a private environment, you can also publish certain visualizations and embed it in your blog, or in our case, in media visualizations. And it also has an API, which is great. And we used it to build the public database that we released a couple of weeks ago. On May 9th at 2 p.m. Washington, D.C. time, we released the improved version of the Offshore Leaks database in this URL. Basically, the Offshore Leaks database combined the data that we had before from offshore secrets, offshore leaks, and the Panama Papers data. Only the structured data part, so only the data about the companies and the companies in tax havens, in offshore jurisdictions, and most importantly, the people behind them. Tax havens sell secrecy. Tax havens sell anonymity, because most of the corporate registries in tax havens are not public, or only include nominee names. And this database included the structured information from these 2 leaks, so not documents. We didn't publish all the documents of the Panama Papers, for example, just these internal databases of the offshore service providers of these 2 leaks. And thanks to that, we were able to break the secrecy of these tax havens, or part of the secrecy of these tax havens, because with this database, you're able to explore the names of who's behind companies in British Virgin Islands, who's really behind companies in Panama, who's really behind companies in the Cook Islands. And you're able to see, for example, that, Carmen Thyssen is actually behind the company that owns this Van Gogh that I just showed you. So this is how the database looks like. But better than showing you a screenshot, I want to show it to you live. I hope you're seeing the database live, and basically in here you can find out who's behind almost 320,000 offshore companies. You can enter any topic. You can see the popular searches today. So for some reason, Japan is very popular today, and these 2 other names. We had Donald Trump trending for several days. There's some mentions of Trump, but not many connections to him. But there are some other connections to, let's say you're a Harry Potter fan and want to see whether Emma Watson is in it. Of course, you need to search with quotes. It's like a Google search. It gives you a better search. And yes, she is there. You could actually see that she's connected to one address, connected to one entity, linked to the United Kingdom. She appears in the Panama Papers data, which, by the way, it's current through 2015. And here you can see the graph. Let's put it in full screen mode here. And you're able to see just by clicking the dots. Let's see who else is in Falling Leaves Limited, which, if you want to know more, here you can see that it's a British Virgin Islands entity incorporated in September 2013. You can double click on the node and you can see other names, other officers. She's here, as you can see, another data quality issue. Emma Watson and Emma Charlotte Dewar Watson is the same person, but of course the name is not the same, so we did not want to merge that, because there's, you don't know if it's the same person from a programmatical perspective. And, you could keep expanding the dots and seeing some of the addresses, and you already see a London address here, another London address here, a Jersey address here, all connected to this British Virgin Islands entity. Let's exit full screen. This is just one example. You can also see the connections in a table format. And this is basically what the offshore leaks database allows you to do, is explore these names and find people that you may know, or stories, or if you're a tax agency, it would allow you to check the names and see whether these people are actually paying taxes or not back home. Let me just go back to the presentation and explain you a little bit about the nodes and the data model. There are just a few more minutes left so that we can take questions. As you can see, the nodes are just 4, so very simple data model. We have officers, who can be people or companies that are connected as directors, as shareholders, as beneficiaries to entities. Intermediaries are those law firms, banks, or any intermediary that asked Mossack Fonseca to create the entity for the officer. And then there are connections to addresses. I have to say, there may be duplicates. When you look into the data, there may be duplicates because we did not do merging on the names unless they had their same internal code. But unfortunately, not all the databases had internal codes for all the names. So unique identifiers, that means that some names may be the same, but we did not merge them because they did not have the same unique identifier. So there may be duplicates. There is dirty data. There is dirty data, especially connected to addresses. I said super dirty data because, of course, addresses were not standardized. We tried to keep the data as close to the source as possible. You can see a bit more of the data model here in this graph and the possible connections and how they interconnect. The database has around 840,000 nodes and 1.3 million relationships. This is a final figure. Before I had given a slightly different figure, but that was previous to finalizing the database. So now you can see the updated figure. And I want to encourage you to not just explore the database, please go to offshoreleaks.icij.org, but also to download it because we have made it public under open licenses. Of course, if you use it, just please credit us. We used Creative Commons licenses for attribution, share alike, and open database license too. So you can use it, you can reuse it, and the best of it is not only you can download it in CSV, but you can also download it in Neo4j. And we made it a special package where you can actually download that file. You don't have to have Neo4j installed. You just follow the README, and you'll be able to have Neo4j and the offshore leaks data together at the same time. So basically, you don't have to install Neo4j. Everything is together. You don't have to worry about the import. We tried to make it easy for you, and we got a great support from Neo4j to make that happen. So please use it and download it and try to explore connections, because if you use it and you download it, you're able to do things like this query to find shortest path between two officers. And this is an example of the queries you will be able to do if you download the Neo4j version, and you'll be able to explore the data in its full potential, even more than many of our reporters. If you find stories, please come back to me. I think I've left my contact at the end of the screen. We will be doing stories. We're still doing stories. We have added 80 reporters since we published. Some of them, half of them, come from new media organizations, including the New York Times and the Washington Post, who are right now in this very minute looking at the data for more stories. Let me give you one disclaimer though. Everything that you're going to be seeing is legal, because creating a company offshore in a tax haven is perfectly legal. What is illegal is not to report it. And only tax agencies know if the entity and its assets have been reported. But as Obama said a few days after we published, the fact that everything is legal is exactly the problem. So that is why we believe that publishing this data had made sense, and we are helping the public debate about what corporate registries should include and how these corporate related data should be public. As you can see, at ICIJ, we work in teamwork, not only between reporters, but also with different technology companies, including Neo4j and Linkurious, who gave us great support for this investigation. So if you are also connected to a technological company, you have software that you think can help us, please contact me, and we'll try to see whether we can work together in the future projects. And I have to say, sorry for, how do you say, this shameless plug, but I have to remind you that everything you've seen, all the work we've done, is thanks to donations. ICIJ is a nonprofit media organization. We work with donations of foundations and philanthropists and people like you who think that we do great work. And thanks to that, we keep going. So if you think that our work is great and you want us to keep doing things like this, as I said, you can donate your technology, you can donate your time. If you have some dollars to spare, you can also donate some money and help us keep continuing to do our work in donate.icij.org. I want to leave it to the questions and say that this is the end of my presentation, but maybe it's not the end of it. I hope to be here next year with you, talking to you about the next biggest leak in journalism history, and trying to speak about how we use technology and graph databases in this new investigation. So I think I'm going to open it up for questions now and leave it to you, Corey.
Thank you. Thank you so much, Mar, for that excellent presentation. I thoroughly enjoyed it, and I'm sure our attendees did also. We will go ahead and begin asking the questions that are submitted, and I'll remind the audience you still have time to submit your questions. We'll take as many as we can live, and with the ones that we don't get to, we will go ahead and email you a personal response. So Mar, our first question is, with such a massive amount of data released, how and where did you start?
Well, I think that was a question that came in before the presentation. I hope that was answered throughout the presentation. But as you can see at the beginning, what we try to do is spend time with the data, understanding what was in front of us. I think that we've learned through the years to spend time looking at the data before getting people on board. We spent months understanding what was in front of us, what type of file formats it had. Let me remind you, let me actually, wait, just hold on. Clicking, okay, cancel. Sorry, I was about to leave the webinar. Just hold on, I want to show you the screen and put the screen so you can see, where do I have this? Here. Yes, so now you probably see a bit better. When we looked at what was inside those 2.6 terabytes, we looked at the fact that there were emails, that there were a lot of PDFs, and that sets the work that you have to do, basically, right? you see that they are around, a third of the leak were images. Well, we knew we had to do a lot of optical character recognition, that we needed to do parallelized work so that we could do that faster. And we also knew that we needed to have a searchable engine to search them. We also knew right when we looked into this that we also needed to look at the data in a database format. And knowing that it was companies, we knew right from the start that we needed to use a graph database. So that's basically where we started. It's looking into the leak, looking into the 2.6 terabytes, and understanding the different files that we had, and then that set the type of tools that we needed to use.
All right, great. I'll go ahead and give just a moment. We're going to correlate a few questions. We're seeing a huge influx of questions, so I do want to take a moment and thank the audience. Thank you so much for sending those. We will not have time to answer all of them, but Mar will go ahead and get back to you, and we'll be sure to answer all of those questions personally. All right, we'll get back to the questions. Mar, how did you go about creating the nodes and relationships?
Great. Well, as you can see, the database records, we basically started looking at those records and seeing whether there were unique identifiers of the names. And we immediately found that there were basically 4 types of entities. That we had companies or entities, because it was not just companies, but also trusts and funds offshore. And those had a unique identifier given by Mossack Fonseca in this case, in the case only of the Panama Papers, but it was similar in the offshore leaks data. We also saw that there were intermediaries, the clients for Mossack Fonseca, and those had a unique identifier too. And then we also had records that were connected to shareholders and beneficiaries. And unfortunately, those did not have unique identifiers. But we had the unique identifier of the company, and we had the unique identifier of the intermediary. So thanks to those unique identifiers and those relations, creating the relationships were very, very easy. For the offshore leaks database, we actually used some algorithm to try to find similar names. So if you actually look at the database in a website or in Neo4j, in the Neo4j download, you'll be able to see that there are some links that actually say similar name and address, similar address. So those were links that we established based on, on similarity between the different nodes.
All right, excellent. I think this next question ties in really well. It is, did you have scaling issues with Neo4j? And to expand on that, it says, with such a massive data size and the fact that you can't partition Neo4j across multiple machines, it must have been a very large machine. Can you share some information around that?
Yes, although as you can see, I'm not the technical person in the team. We also have we actually had, especially for this project, a system administrator helping us with the setup. Basically, it may seem big, but it's not that big, having, a database of, less than 1 million nodes and 1.3 million edges. It's not that big, but yeah, it is big, and especially for us, it was not just the size. It's that we got a lot of traffic. So let me give you some figures. In the first 6 days of publication, we got more than 4 million visitors into the website and 34 million page views. And we were able to have that because we have basically behind the database, we have several machines. We actually had 10 instances up and running, and each of the instances had its own local version of Linkurious and Neo4j. So basically, they were serving all the traffic. We also used a lot of caching, and that allowed us to support all this traffic. And the machines used auto-scaling. So, we basically, if we received more traffic, the machines auto-scaled. So we did not have problems. I mean, since the moment when we launched, the site has not been down at all. And that's because we had set up this auto-scaling system. I have to say that it was great to have Neo4j support. And basically, they supported us as a client and basically looked into the configuration and helped us tweak the configuration and the system so that it was able to receive all this traffic.
Excellent. Thank you. We have about 3 minutes left, so I will just remind everyone in the audience that we will go ahead and email you the recording of this presentation as well as the slide deck, so check your email for that. We have about 3 minutes left, so we'll take as many questions as we can and get back to the rest via email. So Mar, our next question is, how much time was spent translating data in text documents into the graph data set?
So it's difficult to answer because we received the data in chunks. So there was incremental information that needed to be also processed. But it took us several months to reconstruct the database. And but it's not because it was difficult to create a graph database. It's because the database records were it was a deconstructed version of the database, let's say. So we needed to do reverse engineering to actually reconstruct it. And that's where the time was spent. Once we had the data in SQL, converting it to Neo4j was pretty simple. It took us a couple of weeks because we needed to do some transformations, but the transfer, the real conversion, it doesn't take that long. And then plugging it into Linkurious, it just takes seconds if you have it set up.
All right, thank you. Our next question is, did you integrate with any other data sources outside of the leaks, for example, companies' house registrations, and other sorts of documents such as voter registrations, marriage records, etc.?
So we used all those sources for reporting, not for the public database. However, if you are seeing my screen, you can see that we actually linked to open corporates. So for example, in the case of Emma Watson that you're seeing, or let's actually look at Falling Leaves better. In the case of Falling Leaves, you can actually search Falling Leaves in open corporates. So we have some links to other, other companies. Of course, we don't know if it's the same company, but you're searching the same term and without having to do that search. Right now, this is the status of the database, but we may be able to improve it and connect it and do some linked data with this if we have time in the future.
All right, we'll take one final question, and that is, are you working on discovering or building complex patterns so to help build new bases to improve law systems for these issues?
So right now, we are working on more stories. I have to say there's a lot more work to do, and that's why we're also opening up this data to the public. We count on data scientists. We count on experts to look at this database. That's why we have a download option. We count on the public to look and see what stories we missed. But the thing I'm most excited about is data scientists and tax experts to look into this data and start analyzing the trends and patterns that you guys with your expertise can find and that we may have missed. I think that there's much more that we could do with this data. From a journalistic perspective, we didn't do things like semantic analysis, we didn't do entity extraction, we didn't do data mining. We just didn't have time. And of course, our knowledge on graph databases is limited. It's getting better, but it's limited. So I'm counting on all these Neo4j fans and experts that are following this tutorial and webinar to actually just log into the database, get into the database, download, and try to start analyzing the real patterns that are there and that we may have not exposed yet.
All right, well, thank you so much, Mar. We have thoroughly enjoyed having you and hearing your presentation on how the ICIJ unraveled the Panama Papers. Thank you again so much for joining us today, and thank you to our attendees for listening. You can go ahead and submit your questions for the next about 30 seconds and check your emails for answers to those. Just a reminder, we will go ahead and send you the recording via email. Thank you so much, and we will see you on another webinar soon.